One of the uses of factoring in mathematics is to solve some quadratic equations. But let's take a step back and review what is a quadratic equation. We've seen some in the past that we've called convenient quadratic equations, and I'll talk about what that means in a minute. If I say 2x squared plus 5x plus 3 equals 2x squared plus 7x minus 9, if I want to solve this, first, the reason why this is a quadratic equation is because of these exponents. It's in the degree of 2, making it a quadratic equation. We know that means exponential. And these are called the quadratic terms because they are the ones with the exponent of 2. It's been convenient so far because the first step, I can always, whatever I do to one side of an equation, I can do to the other. So if I subtract 2x squared from both sides, I'm back to my plain old linear equations that we've been dealing with all along. I just want to isolate the variables, so I'm going to get the variables all alone on one side, bring the variables to one side, the constants to the other. This gives me 12 is equal to 2x, making x equal 6. We've seen quadratics of this sort so far that are easy to solve because the quadratic terms essentially cancel out. If I take the same amount off both sides, I have just a plain old linear equation. Always work though. So the next method of solving quadratic equations is going to be by factoring. But before we even get there, let's just take a step and just say x plus 5 times x minus 1 equals 0. Here's an equation where one number times another equals 0. Although it looks a little fancy, or perhaps not as clear as saying, I don't know, 2 times 0 equals 0, if I'm saying one number times another equals 0, then one of these must be 0. And though that's obvious, this is the big concept on which we will be building this whole idea of solving by factoring. So if one of them must be 0, then either x plus 5 is or equals 0, or x minus 1 is or equals 0. This is called setting each of these factors. This is one of the factors, and this is the other. So when I say I am setting each factor equal to 0, it just means I'm going to say that x plus 5 is 0, or x minus 1 is 0. What we know must be true if when I multiply them, they equal 0. So I'm going to solve these just like we've always solved them. These are very, very simple little equations. And what this tells me is that the solutions are -5 or +1. Notice there's more than one solution. Going back to our definition of a solution to an equation, it's anything that makes the equation true if I plug it in. So let's start by plugging in -5. -5 plus 5, I'm plugging it into this equation here. -5 plus 5 times -5 minus 1 equals 0. Well, is that true? Is 0 times -6 equal to 0? Yes, it is. So that is, in fact, a solution. I can now plug in 1. 1 plus 5 times 1 minus 1 equals 0. Is that true? Is 6 times 0 equal to 0? Yes, it is. So there are two solutions, and we write them using set notation. The two solutions to this equation are -5 and +1. We know they're solutions because we've plugged them in. So let's try another. We start out with 2x minus 3 times x plus 7 is equal to 0. Again, if this number times this number equals 0, then one of them must be 0. So I set each factor equal to 0 and solve. This gives me 2x equals 3, divide by 2, and you can keep it just as an improper fraction. X is -7. So my two solutions are x equals, whoops, see, even I have trouble with the brackets sometimes. X equals, that's better, -7 or 3 over 2. Okay, but of course, isn't everything that we do start out that easy? So, always, things get a little bit harder. If I say to you that n squared minus 10n is equal to -21, the problem here is that it doesn't equal 0. At first, students might say, oh my goodness, what do I do? Well, we've long known that whatever I do to one side, I could do to the other. So I can get one side equal to 0 by saying n squared, I can add 21, so n squared minus 10n plus 21 equals 0. Now I can factor. There's no common factor, so I've got n and n. The signs are the same, they're both negative, 3 and 7, so n is equal to +3 or +7. You know, I did this in my head, but of course you can always show the work. What if I had a thing where it says 10x squared equals 13x plus 3? Well, I want to get one side equal to 0, and I could say, I could subtract 10x squared. What I'd have, one side would be equal to 0, -10x squared plus 13x plus 3. The problem is that we're just really not used to factoring with the quadratic term being negative. So one solution to that is to multiply the entire equation by -1, which would give me 10x squared minus 13x minus 3. Or else, just going back to the beginning, probably the easiest thing to do is just tell yourself, I want the quadratic term to be positive, so I'll bring everything else over to its side. Either way, I'm going to end up with 10x squared minus 13x minus 3. From there, I need to factor 10x squared minus 13x minus 3 equals 0. So there's no common factor. Ding, 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 ding. Must guess and check because there's a coefficient, which means it doesn't multiply to 3 and subtract to 13. Instead, I have to guess. I'm going to guess 2x and 5x, and I don't know, 3 and 1. And my signs have got to be different. This gives me positive 15x minus 2, so 15x, and negative 2x gives me positive 13x. I'm almost there. Everything is right except the signs, which means all I have to do is change the signs, and I'm there. That makes this negative 15 and positive 2, which is negative 13x, so I'm there. Now I need to set each factor, I guess I don't need the parentheses, set each factor equal to 0 and solve. So I add 3. It's these that have coefficients that you really do need to show the work. And I have 5x equals -1. So my two solutions are x is equal to -1/5 and 3 over 2. It doesn't really matter what order you put these in, but usually they go from least to greatest. So let's just summarize what we've got here. The thing I want to do is get one side equal to 0. And you want your quadratic term positive. Oops. Quadratic, Q-U-A-D-ratic term positive. Just makes the factoring easier. Okay. Then you want to factor completely. Beginning tomorrow, we're going to go through all of the different steps. But don't forget, that means GCF, and then 2 terms. You're going to be looking for a difference of squares. I probably should do one like that. 3 terms, try the try, but watch out for the ax squared. You have to guess and check. Ding, 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 ding. 4 terms, you group, and you keep factoring until you're done. You're done when nothing can be broken down further. Okay, and then the final step is set each factor equal to 0 and solve. Okay, the whole thing is based on the idea, remember, that if there are 2 numbers multiply to give you 0, that means one of them must be 0. So let's just try one that looks like this. 18n is equal to 2n squared. All right, so clearly one side doesn't equal 0. This is the quadratic term, so I want to bring everything else over here. So 0 is equal to 2n squared minus 18n. Now I need to factor. The first step of every factoring problem is to look for a greatest common factor. That factor is 2n. What's left is n minus 9. Now you might think that this is a difference of squares, but it's not, because n has an exponent of 1, which means it's not a perfect square. Perfect squares all have exponents that are odd. So I go straight to set each factor equal to 0. Either 2n is 0 or n minus 9 is 0. So I divide by 2, n is 0 or 9. And those are my 2 solutions. N equals 0 or 9. Okay, so I looked at this problem and I actually thought it was a difference of squares. However, it's not. Let's see if I can see one that is. What if I say 25x squared equals 16? Okay, so once again, I want to make sure that my quadratic term is positive, so I'm going to go this way with the others, because that means 25x squared is positive minus 16 is 0. When I look for a common factor, there is none. There are 2 terms, so I want to see, is it a perfect square minus a perfect square? And yes, it is. So I factor that as the square root of 25x squared, square root of 4, plus and minus. Now I'm going to set each factor up equal to 0 and solve. So my 2 solutions are x equals negative 4/5 and positive 4/5. No room for the bracket, really. I want to add 2 types of examples that didn't make it to this original version of the video, and do come up in homework exercises. If, for example, something says x times x minus 5 times x plus 3 equals 0, notice there's another factor here, but the same big idea still holds. If this number times this number times this number equals 0, then one of them has to be 0. The only difference is now we say x can be 0, x minus 5 could be 0, or x plus 3 could be 0. That means that there are now 3 solutions. They are x equals 0, 5, and negative 3. By the way, if I did multiply this out, if I FOIL this, I would have x squared minus 2x minus 15. And then if I multiplied that whole thing by x, if I multiply the whole thing by x, I get x to the third minus 2x squared minus 15x. Notice the highest exponent is 3, and there are 3 solutions. Also, if this had been 2 times x minus 5 times x plus 3 is equal to 0, then either 2 is 0, x minus 5 is 0, or x plus 3 is 0. Well, since 2 can't ever be 0, there are still just 2 solutions. And if I multiplied this whole thing out, when I FOIL it, as we've seen before, I get x squared minus 2x minus 15. And when I multiply that by 2, I still have the highest exponent is 2. This is just interesting stuff. It doesn't apply right now. What you need to understand is if there are 3 factors, then each of those needs to be set equal to 0. Sometimes, as in this case, it doesn't yield another solution. The final thing that is, what if it says, and I think I did do something sort of like this, if it says x squared equals 9 plus 8x. Okay? I think we've already talked about the fact that the quadratic needs to be positive. So I know I need to subtract 9 and subtract 8x. But the question is, what order? None of these are going to be like terms. So I have to decide what order I'm going to put them in. The general form for all of these trinomials that we are factoring is that it goes from the highest exponent to the lowest. This is the form that we're used to factoring, so it's important to put it in that order. So now I'm going to do my factoring, x and x, plus and minus. I'm looking for numbers that multiply to 9 and subtract to 8. They are 9 and 1, and 9 needs to go with the negative because it turned out negative. That means that x plus 1 is equal to 0, or x minus 9 is equal to 0. X is negative 1, or x is 9. And these are solutions because if I plug them in, if I plug in negative 1 here, whoops, if I plug in negative 1, I find out that negative 1 plus 1 times negative 1 minus 9 equals 0. And that's true because this one is 0. If I plug in 9 to the other fact, if I plug in 9, I get 9 plus 1. And 9 minus 9, well, 9 minus 9 is 0, so 10 times 0 is 0. 2 solutions, negative 1 and positive 9.